All right, Algebra 1B students, welcome to part 1 of lesson 9.3 on solving quadratic equations. We now know how to graph quadratic functions, and now we're going to look at solving them for x. All right. First, we need to talk about two crucial conditions that we must have when we want to solve a quadratic equation. Okay. Two crucial conditions, 1 and 2, right here. Okay. Now, number 1, the quadratic expression, all the quadratic stuff, must be equal to 0. Okay, must be equal to 0. So on one side of your equal sign, you must see 0. And on the other side of your equal sign should be all of your quadratic business. All right? So this is good. This is bad because that's not a 0. Bad. All right? Also, the quadratic expression must be in standard form. Now, standard form, remember, means exponents that are biggest start on the left. So 2, 1, 0, this is in standard form because we go x squared to x to no x's. This here is not in standard form because the x squared does not come first. The one with no x's comes before the one with x squared. That's no good. That's bad. Okay, so if we want to solve a quadratic equation, it has to look something like this one. Okay, and not like this one. Now, once we have our quadratic equation in that form, where it's standard form equal to 0, then there are a couple ways that we can solve quadratic equations. Right? And one way is to graph the related function ax squared plus bx plus c. We're just going to graph it, just like we normally do. But instead of always saying equals 0, we'll just put a y equals and make a table of values like we were doing previously in our previous sections. Okay? The solutions of the equation are the x-intercepts of the related function. Now, x-intercepts, if you don't remember, means where my graph crosses the x-axis. So there's my x-axis, and I've got 2 points where my graph crosses that x-axis. Those 2 points are my answers, my solutions. Okay? A quadratic equation can have 2, 1, or no solutions for the purposes of our class. Right? 2, 1, or no solutions. The solutions have special names. They're sometimes called the roots of the equation, and they're sometimes called the zeros of the equation. Either one. You should recognize both of those words, roots of the equation and zeros of the equation, as just talking about answers. Those two words mean the answers for x, the solutions for x. All right? Now we'll look at an example of this graphing method, and then I'll have you do some, and we'll be done. Should be a pretty short and quick video tonight. Here they're asking us, what are the solutions of each of these equations? Use a graph of the related function. Okay? So again, when we see x squared plus 1 is what they want us to find the solutions of, we graph y equals x squared, minus 1. We graph y equals x squared minus 1. So y equals x squared minus 1, that graph looks like this if we made a table of values. A 0 in for x means negative 1 in the y. 1 in the x means 0. Negative 1 also means 0, and so on, and there's our function right there. Now, because we see 2 places where that equation crosses my x-axis, we know there are 2 solutions. And it looks like it's x equals positive 1 and x equals negative 1. Or as your book writes it, plus or minus 1. Okay, so we used the graph. We looked at the graph. We saw two places where it crosses the x-axis, and we have two solutions, right? When they want us to say where x squared equals 0, we're going to graph y equals x squared. Here's our graph for that. It's a regular looking x squared graph. And I see only one place where that graph hits the x-axis. So there's only one solution. When your graph just comes down and touches, or just comes up and touches that x-axis, there's only one solution, and that is 0 in this case, the point where that graph comes and touches the x-axis. It touches at x equals 0, not left or right at all. And finally, they will ask us to do x squared plus 1. So we'll graph y equals x squared plus 1. And this is what our graph looks like here. There's our graph. Our question, of course, is where does that cross the x-axis? But in this case, the answer is nowhere. It never crosses the x-axis. It doesn't touch that blue line, that x-axis. So there is no solution. No solution. Okay. So you can see how we have three options now. Two solutions here, one solution here, and those solutions here. Those are your three options. Now, I would like you to graph these three quadratic equations and tell me how many solutions it has and what the solutions are. Now I want to point out to you in the last one here, this does not equal 0, right? So we can't actually solve that yet because we have to get it to equal 0. In order to get that to equal 0, it's fairly simple. We just want to add 25 to both sides. Because if we add 25, now that's 0. Add 25 over here, that's also 0. So really this is x squared equals 0. So we should know that one already. Okay, but especially look at these first two. And that last one, you can confirm what I found up above yourselves. Pause the video. Take a look at these three questions. Tell me the solutions of each one. And then come back and I will show you what the answer should be. All right, in the first one, this should be negative 16. And our graph should look, whatever like this. That. That's a solution, and that's a solution. There are two solutions, and it turns out to be positive 4 or negative 4. X equals positive 4 or x equals negative 4. Okay, now this one here, 3x squared plus 6. There's 6. And my graph would look something like this. This never crosses my x-axis. Right? Never gets down here to my x-axis. So this is no solution. And finally, I hope you confirmed to yourself that when we have x squared equals 0, our graph looks like this. It has one solution, x must equal 0. If you have questions about anything we just went through, make a note to ask me in class tomorrow, please. Otherwise, you are prepared for your practice problem set. And that's all I have for you tonight. Have a wonderful night.